Hello, welcome to Chapter 2, homework questions 65 through 69. Question 65. Examine the shapes in your shape toolkit. Then name all the shapes in the shape toolkit that share both of the following qualities. They only have one line of symmetry, and they have fewer than 4 sides. So you need to make sure you get out your shape toolkit so you can look at the different figures and, once again, name all the shapes that have both qualities, one line of symmetry, and fewer than 4 sides. So out of the 16 shapes, there are 2. One is the isosceles triangle, and then more specifically the isosceles right triangle. Maybe, it has fewer than 4 sides, so you're looking at all the triangles, but have one line of symmetry. Some of you were thinking the equilateral triangle, but there's more than one line of symmetry in an equilateral triangle. So once again, isosceles triangle and isosceles right triangle. Question 66, examine the diagram below. Then use the information provided in the diagram to find the measures of angles A, B, C, and D. For each angle, name the relationship from your angle relationship toolkit that helped justify your conclusion. For example, did you use vertical angles? If not, what type of angle did you use? So once again, looking at the diagram, we're trying to find angles A, B, C, and D and justify our reasoning. So we can just kind of start filling things in and see where we get. We do hopefully recognize that we have one set of parallel lines, and it is cut through by 2 transversals, so we have to pay attention to that. We could start by finding C, because if this is 148 degrees, this angle right here, then this angle forms a straight angle with 148, so we know that C plus 148 degrees is equal to 180 degrees. And then if you subtract 148 from 80, that's going to be 32 degrees. So we know C is equal to 32 degrees. Then we also know, and I'm going to erase some of this as we go so I don't have so many lines, but now if you look at C and D, because this is the this is the transversal that cuts the 2 parallel lines, what is true about these 2 angles? These are your alternate interior angles. So what's true about alternate interior angles? They are congruent, which means their measures are the same. So if C is equal to 32, then that means D is equal to 32 degrees. And make sure you go back and explain why C, because it says name the relationship. So C is equal to 32 degrees because of straight angles. And then also D, we said, was because alternate interior angles when we're using 2 parallel lines. So alternate interior angles are congruent, or their measures are equal. Either way you want to write that. And once again, because of the 2 parallel lines. All right, let's move on to A and B. So we know that 62 degrees, we can find this vertical angle at 62 degrees. That will also allow us to look at same side interior angles. And we know A and B are vertical angles, so we know if we find B, we also have A. So because of our same side interior angles are supplementary, we know that 62 degrees plus B is equal to 180 degrees, and if you subtract that, it will leave you with 118 degrees for B, and then A we also know is 118 degrees because of vertical angles. So we know this one's true because of vertical angles, and we also know that that B is 118 degrees, and there's different ways that you can do this, but I used vertical angles first, and then second I use same side interior angles. Once again, because 2 parallel lines are cut by a transversal, though. If they weren't parallel, then those wouldn't be true. Question 67, examine the triangle below. If the measure of angle D is 48 degrees, and the measure of angle F is 117 degrees, then what is the measure of angle E? Well, because the sum of the angles of a triangle are equal to 180, we know 48 degrees plus 117 degrees plus the measure of angle E is equal to 180 degrees by the angle sum theorem. So we add 48 plus 117, that's 165 degrees, plus the measure of angle E is equal to 180 degrees. Subtract the 165 degrees, and you get the measure of angle E is equal to 15 degrees. Once again, we use the triangle angle sum theorem to identify that. On part B, solve for x if the measure of angle D is 4x plus 2, and the measure of angle F is 7x minus 8. So this measure right here we're saying is 4x plus 2, and the measure of F is 7x minus 8, and the measure of E is 4x plus 6. And then we can find the measure of angle D. So we're going to do the same thing, but it's in terms of x. So we'll take 4x plus 2, that's one angle, plus 7x minus 8, it's a second angle, plus the fourth angle, 4x plus 6, is equal to 180 degrees. And we can combine our like terms, so 4x plus 7x plus 4x is 15x. You have 2 minus 8 plus 6. That looks like those actually cancel out. And so that'll be plus 0, and then that's equal to 180 degrees. And then you can take 180 and divide it by 15, and you will get 12 degrees. So the x value itself is 12, but we want to find out what the measure of angle D is. Well, now that we know what x is, we know that the measure of angle D is equal to 4x plus 2. So we'll say 4 times 12 plus 2, and that's 48 degrees, plus 2 degrees is 50 degrees. So we now know that the measure of angle D is equal to 50 degrees. Question C, if the measure of angle D, F, and E are equal, what type of triangle is it? Well, if the measure of all three angles are the same, if you think about this, this would be 180 degrees, and if they're all the same, we can divide by 3, which makes them all 60 degrees. This would represent an equilateral triangle. And so if the angles are all 60 degrees, it also makes their side lengths the same measure. Now, they can be different measures for different sizes of triangles, but they would all be equal. Question 68. Plot triangle ABC on graph paper. And I'm going to stop right there. Let's go ahead and plot those points and graph it. All right, so we've done that. Now we want to take triangle ABC and rotate it about the origin. So we're going to rotate it about the origin at 0, 0, 180 degrees to become triangle A prime, B prime, and C prime. And then we're going to name the new coordinates. So we want to rotate. If you want to use tracing paper, you can rotate it half a circle. That's 180 degrees. And see, you can tell it's going to fall in quadrant 3 maybe, but, where are those points going to be located? And so now we have rotated 180 degrees. Here are your new coordinates for A prime, B prime, and C prime. And once again, draw on the triangle as well. Part B. This time, take triangle ABC and rotate it 180 degrees about point C to form your new triangle. We're looking for coordinate B double prime. So we're going to take this as our center of rotation and rotate it 180 degrees. So point C stays in the same place. If we're rotating 180 degrees, then this point A needs to go this way 180. So if you can count the distance from A to C. So if I go up 4 over 1, then I go up 4 over 1 again, that would create my new A prime point, and it's not asking for it, but that would be at 4, looks like 11. And then if we do the same thing with B, now B, in terms of going in this direction, we can count how far it is away from C, so 4, 5, 6, and then over 3, and I can repeat that, 6, and then over 1, 2, 3 is going to be somewhere up here. And since I went over 3 from my point on this one, that'll be right here at 8. And then 6 up from where you're at right now, which is at 7, would be 13. And that's supposed to be B, not C. So B double prime is located at 8, 13. Part C, if triangle ABC is rotated 90 degrees clockwise about the origin to form our new triangle, what are the coordinates of point A triple prime? Part C, if triangle ABC is rotated 90 degrees clockwise about the origin to form the new triangle, what are the coordinates of point A double prime? So as we rotate around the origin this time, and we're only going 90 degrees clockwise, we're going to focus on A, and we're going to rotate it. And when you rotate it 90 degrees, once again, use your tracing paper, rotate it 90 degrees, and it will now fall at 3, -6. So for part C, A triple prime, 3, -6. And once again, with rotations at this point, really try to focus on using that tracing paper to help you identify where these points are going to be located. Question 69. Examine the graph, and then let's answer some questions. So we have a line. You can see that maybe it's going through at 0, 3. And then on the x-axis, it looks like it's maybe going through 4.5. So let's kind of wait and see what we need to answer here. Part A, find the equation of the line. So we do need to know the y-intercept, which we have at 0, 3. The slope, though, we need to find another point that it intersects nicely, because at the x-axis it doesn't. So it looks like it intersects again right here at 3, 1. So our slope, you can do your slope triangle. You're going down 2 and to the right 3. So it looks like we have a slope of -2/3, which is enough information to write the equation y equals -2/3 x plus 3. Part B, is the line y equals 3/2 x plus 1 perpendicular to this line? And how do you know? Well, remember, we need to look at the slope, and perpendicular lines have opposite reciprocal slopes. So is 3/2 and -2/3 opposite reciprocal? And the answer to that is yes. It's the reciprocal, and one's positive and one's negative. And so we know, once again, that because the slopes are opposite reciprocal. Part C, on the graph paper, graph line AB. If AB is, so let me erase what we have up here. I'm going to have to use this one. If A is at -2, 4, so that's right here, and B is at 4, 7, 1, 2, 3, 4, 5, 6, 7, so it's a little bit off here, but we'll make it work. Then find the equation of line AB. So we're looking for this equation of this line. So with this one, because the graph and everything else, I don't know exactly where things are happening, I'm going to go ahead and just use the information. We can use the 2 points to find the slope. So the change of y, 7 minus 4, and the change of x, which is 4 minus -2. That will give us a slope of 3/6. And if you have a nice graph on your graph paper, you probably could have recognized that it went up 1 and over 2. Now we have that. Where is it crossing the y-axis? Well, we'll use our equation y equals mx, or sorry, the y-axis, y equals mx plus b. Use one of the points. I'll use the point 4, 7, and the slope that's equal to 1/2. And we get 7 is equal to 1/2 times 4 plus b. So 7 is equal to 2 plus b. Subtract the 2, and b is equal to 5. And once again, maybe you recognize that from your graph. Mine was a little bit harder to see. I didn't actually intersect nicely on mine. So y is equal to 1/2 x plus 5. So by doing it algebraically also, I know it's accurate. On part D, find the equation of line AC if line AC is perpendicular to line AB from part C. So we want to find an equation that is perpendicular to my line up here, which is y is equal to 1/2 x plus 5. Well, if I know the slope of this one is 1/2, then its perpendicular slope is opposite reciprocal, which would be -2. So I can write any equation, y equals -2, as long as that, my slope's -2. It doesn't matter what my b value is. So I'm just going to put plus b because it doesn't matter. It will always be perpendicular because of the opposite reciprocal. So, and then once again, maybe I can even write, b can equal, or I'll just put b as a real number. So it can be any number. And I think that answers the last part of question 69.